Leaked encryption keys, offensive material, and errors suggest that an editable blockchain is worth reflection. Situations exist where the ability to go back in time and perform an undo appear to make sense. In these contexts, we imagine a fair and balanced world operating in harmony, a utopian version of the modern Internet of Things. Is this really a conversation about blockchains or the struggle for freedom and expression and the right to be heard? Hi, I'm Peter.nichol, healthcare executive, passionate about digital innovation and blockchains. I work with small and large companies to explore blockchain's potential for healthcare and establish growth models for multi-sided digital platforms. Today we'll be covering 5 topics. First, what is a redactable blockchain? Second, we'll explore the argument in favor of editable blockchains. Third, we'll discuss how the concept adapts to different blockchain types. And fourth, we'll consider what happens if there are HIPAA violations. Lastly, briefly, we'll get into how this works in practice. Censorship has been explained as the actions taken the best interests of the public, a benevolent public concern for mortality, China's censorship of WeChat for Uber, the decision by the Indian film to cut 94 movie scenes about Punjab's drug problem, Michelangelo's 1565, The Last Judgment. Freedom of speech is the right to articulate one's opinions and ideas without the fear of government retaliation, censorship, or societal sanctions. It's the right to be heard. Does a network hold trust if all voices are not heard? Are we talking about the ability to edit a transaction or present proof of trust, proof of immutability? These concepts are mutually exclusive. Our first topic, what is the redactable blockchain? 4 academics, 1 from the USA, 2 from Italy, and 1 from Brazil, are the inventors behind the new framework to rewrite or compress contents of blocks. Their joint paper, Redactable Blockchain, or Rewriting History in Bitcoin and Friends, was published August of 2016 and expands IBM Watson's earlier chameleon signature research, published in 2000. As explained in their original proposal paper, a blockchain is editable by adding a link to each of the hash chains. Think of a block-to-block link as a lock, physical lock, in which a key is required to unlock it. In a permissionless blockchain, there is no key, making the series of transactions or blocks immutable. In a permission blockchain, this trapdoor key can be given to miners or given to a centralized auditor. Even shares of the key could be distributed among several different authorities. In this context, these operators each will have the ability to repair blocks. For example, blocks can be deleted, modified, and even inserted into existing blocks. Our second topic, let's explore the argument supporting editable blockchains. The authors come from varied academic backgrounds. Giuseppe is a professor and the director in the computer science department at the Stevens Institute for Technology. Bernardo Magri is a researcher at Sapienza University of Rome. Daniela is an assistant professor at the University of Trenton, and Wharton is a researcher at the University of São Paulo. This week, I had the good fortune to speak with Bernardo Magri, one of the visionary authors behind the editable blockchain concept. He conducts research on both the theoretical and practical aspects of cryptography. He joked, working with cryptocurrencies is a total shot in the dark, as the community's reaction to the work can be completely unpredictable. You never know. Will they love your work? Will they hate it? It's fair to say the industry loved the work on redactable blockchains. He said there's one thing the public often gets wrong. The public has trouble understanding the inner workings of blockchain technology. Therefore, it's normal that the public also has trouble seeing the benefits of this technology over a simple centralized database system. Adding a redactable blockchain feature does not make it centralized at all. The blockchain will continue to operate as usual, and depending on how the chameleon hash is shared, the trust assumption could remain exactly the same. Redactable blockchains are possible when trusted entities are limited, a variation of M of N multisig. Do we need a blockchain with a delete button? The authors identified two industry approaches for the facilitation of blockchain technology to implement decentralized services and applications. First, an overlay on top of Bitcoin, and second, the creation of an alternative blockchain. There are four motivations behind the desirability of redactable blockchains. First, abuse, the ability to correct the storage of arbitrary messages. For example, Bitcoin has already been abused with offensive material having been cemented in the walls for eternity. Second is rewritable storage. Classic blockchains do not scale and waste precious resources. Rewriting presents new storage options like a CDR. Third, the ability to expunge. The inability to expunge permits the deletion of records if required, as in the case of medical record errors, sensitive information when it's necessary by law to correct it, or when personal encryption keys are leaked or stolen. Fourth, inter-entity interactions. Consolidation is hard to achieve with immutable blockchains. This removes the impossibility of consolidating past transactions without affecting any subsequent blocks. This feature is necessary to combine distinct accounting structures, budgets, or transactions. Our third topic, adapting the blockchain frameworks and the different types of blockchains. The authors anticipated the next logical question. How are keys managed across the three different types of real-world blockchains? First type, private blockchains. The ability to write is bestowed upon a central authority. This example is straightforward, with the trapdoor key given to the central authority with the power to compute collisions, and therefore redact blocks. In short, a single operator has the power to redact. The second type, consortium blockchains. Consensus is predetermined by a finite group of parties. In this example, the trapdoor key is shared among a consortium of parties, and redactions can be made through secure multi-party computation protocols, similar to M of N, multisigs, where multiple consortium parties just grant the redaction before authorization is approved. In short, a select few have the power to redact. And third, the third type is public blockchains, decentralized with no central operator, and any party can submit transactions to the network. A permissionless blockchain such as Bitcoin. The authors offer two suggestions for this type of blockchain. First, distributing a trapdoor key to all parties using a multi-party computational protocol. And second, distribute only to a chosen subset of parties the same trapdoor key set. Under the assumption that the top 7 mining pools in Bitcoin already control 70% of the total networking hashing power. In short, all parties have equal power to redact. Our fourth topic, what happens if there are HIPAA violations? There are many different types of HIPAA violations that can occur. Maybe blockchain can help. I'll run through quickly the most common types of violations. Lost or stolen devices, unauthorized access, employee dishonesty, improper disposal of physical devices, third-party disclosures, unauthorized disclosures of medical conditions, like say in a waiting room of a hospital, emailing or texting patient information, posting on social media, and the lack of prior authorization for the release or disclosure of an individual's PHI, not used for treatment, payment, or healthcare operations. Does an editable blockchain offer advantages to healthcare entities that are part of the healthcare delivery system? To address this question, let's split it into two separate parts. First, the value of blockchains, and second, the benefits of redactable blockchains. Blockchain technology, when applied to healthcare, absolutely can improve the trust between doctors and patients. To answer the second part of the question, we asked Magri. He said the chameleon key is only given to the healthcare privacy officer. However, he does not expect the privacy officer to run the blockchain or produce transactions about payments or even add healthcare records. The privacy officer would be only called when records must be expunged because of HIPAA or other regulatory violations. The role of the healthcare privacy officer is expanding. As data, information, and intelligent analytics become the foundational elements of every healthcare organization, The protection of health information is critical. Critical for growth and critical for strategy. Our fifth topic, in practice. The paper elaborates on the proof of concept. A proof of concept implementation to redact a Bitcoin application using three distinct functions. Generate key to create a trapdoor key, chameleon hash, which computes the hash from the message in a random number, and hash collision, which outputs new random number for reference later. This scenario was then modeled using the regression test network feature of the Bitcoin core network. This framework opens the ability to redact and compress the contents of blocks using blockchain technology. Are editable blockchains merely a form of modern censorship, disguised as flexibility, but really only for a chosen few? Time will tell. Thanks for listening to the whole video. I wanted to offer something else back. A simple analogy allowing you to explain blockchain to anybody. Remember when you were a kid playing Monopoly? Business is similar to Monopoly. And there's a lot of parallels with blockchain. At some point in the game, you had to get up and go to the bathroom. Or get up for a drink. You didn't want to leave the board. But why? Trust. You didn't trust whoever you were playing the game with. Blockchain ensures that everyone is notified of changes, even when you get up from the board. When you buy houses in Monopoly, it's similar to buying real estate. Land registries are recorded in the blockchain. No one can take your property cards with blockchain. When you end up on the community chest and have bills to pay and have to pay $100 for a health bill, it's similar to paying your healthcare bill. Healthcare payments are recorded. No more guessing what you should pay for treatment with blockchain. When you roll the dice and end up on a utility property in Monopoly, you pay a flat fee. A fee based on how large the utility is. Basically, how many that player owns. It's similar to paying a flat fee for your energy. Consumers can choose where their energy comes from with blockchain. Imagine always returning back to the Monopoly board, knowing that nothing had changed. Or if it did change, you knew exactly what changed. This is the power of blockchain. The power to get up from the board with trust. It's evident that industries are very curious about blockchains. Redactable blockchains have just entered the innovation trigger stage of the hype cycle. I hope you found today's video beneficial. Please stay tuned for future topics. Thanks.